Hello and welcome to another video brought to you by me, Jack, V-E-G. Not easy for me to say apparently. Today's video is a viewer's request, and so hopefully I will hit all the key points and not only help him but others that are involved or interested, not involved. Okay, so today's subject is going to be about how to connect your test gear to your stereo gear to see if it's working, or how it's working, or something. The viewer thought that other neophytes, newbies, would be able to benefit from this little tutorial. And I thought, well, okay, sounds fair enough. I'll do just that. Now, please keep in mind, I am not a professional. I am a hobbyist, and I am learning this stuff every day, just like you, as I go. With this, there is great expectation that you know how to work your test gear, and you understand what buttons do and things do and stuff like that. I can't help you because I don't know what you have, and I probably have never played with it, although I'm sure I wouldn't mind owning it. So with that, knowledge of your test gear would be splendid. You don't have to have top of the line, high-end market gear to achieve what we're going to achieve in this video. My only recommendation, I should say, is wires. Try to have the best wires that you plausibly could have. Now, I'm not saying go out and buy gold-plated whizzy-bang wires. No, you don't need to spend $800,000 from audiophile wires. That's retarded. Don't use speaker wires or wires as such. It may work, but please understand that that's going to introduce noise into the signal, and it may also add attenuation, loss of signal. So if you're trying to do something, you're calculating what you're doing and you're expecting a certain number and you're not getting it, it could be because of inferior wires. Use the best that you have. And that's really all you could do. Use the best that you have. If you could afford to buy better and do the work later, fantastic. But just know the cause and effects. Test gear. What are you going to need to do this? Sky's the limit. Here on my workbench, to demonstrate what we're going to be doing, is I'm going to be using a function generator. Realistically, all you need is a audio frequency generator, something that'll cover 20 to 20,000 hertz. Most function generators will do that without an issue. Frequency counter. Again, you don't need nothing spectacular, just something to cover the audio spectrum, which is, again, the 20 to 20,000 kilohertz spectrum. You'll need an Oscope. Well, not necessarily, but it'd be grand if you had one. You could use a sensitive AC meter, and a audio spectrum generator, all of which we'll be using in this demo. Oh, I guess the other important thing to conclude this test, you're going to need an amplifier. That, of course, I guess would be a gimme, right? I don't know. Okay, so how do we do this? Well, first, buy a bunch of test gear. Secondly, buy some wire. Thirdly, buy an amplifier. Once we get all that, you take your wires and connectivity on your gear is going to depend on what you have, age and all that good stuff. Let's just work with what I have. You could adapt accordingly. On my cable, one end is a BNC jack. The cable is RG59U. That goes to the output of your audio frequency generator or function generator. Either one in this case is interchangeable, so if I flip-flop, you'll understand it's one and the same thing. Follow that cable all the way down. My cable has a RCA male connector. On the other end, I'm connecting it to a RCA splitter. One end, as you see, we have a female RCA connector, which splits off into two male connectors. Now, where do you stick this? Well, that's a very good question. It depends on what you're testing. Basically, you're going to put it on the output, you're going to put it on the input of your RCA. And I apologize, I can't get any closer. Maybe, let's see here. That's probably about it. Put it on your inputs, and if you're testing a receiver amplifier, you probably want to test all your inputs just to make sure everything in that circuitry, that switch, is correct. Now, I'm doing this shaky cam, as we could definitely see. Let's see, I lost my wire. So you take that and you put it in there. Make sure your connections are nice and connected firmly, securely. By doing this, this is going to test both sides of the amplifier at the same time. Now, do you need to do that? Not necessarily, but it would make things easier when you want to look at both channels at the same time. If you only have one cable with one output, mono device even, or just a Oscope with one channel, then again, you just work within the means, the boundaries of what you have, and just do the best you can. Got that in. Then into the amplifier, or out of the amplifier, your speakers out. For my stereo, for this amplifier, it's banana jacks on one end, or if I wanted, I could do wires. But since I have the option, I'm going to do banana jack. And then you're going to take your left channel and you port it in over on your channel number 1. Right channel on channel number 2. Then we want to come back to the generator. You want to plug in a frequency of 1000 Hertz, sine wave or square wave, either one would work. Most generators, you can control the sine wave amplitude, where the square wave is generally fixed. But if you could change that, then a square wave works just fine, and sometimes even better. I've got mine set to 1 volt peak to peak. Now you'll need to look at your owner's manual, service manual. It will tell you what the input value of that jack is. If you don't have that data and you can't find it on the internet, start low, work your way high. You need to be very careful about putting too much power into the input of your amplifier, as it could damage it. And that's what we do not want to do. Now, while you do this, you want to make sure your amplifier is either turned off or you've got your volume all the way down. Now, if this is an amplifier that you have no history with, somebody brought it to you, you just bought it, you found it on the side of the road, a word of caution: before you hook up any of your sensitive test gear, take your voltometer, hook it up to the speaker jacks, and turn it on, and see if you've got any high voltage coming out of the speaker jacks. You need to be very careful, and you also need to make sure we have no DC voltage coming out of there. All of that can damage your equipment, your test gear. If you've got such conditions on the output, then you will need to fix that issue before you carry on. Speaking of carrying on, put your amplifier on the port that you plug the wires into. For me, I put it in on CD. And we will turn up the volume a little bit. You don't want to go too crazy, but just crazy enough. Now, while you're doing that, you'll notice your Oscope will make patterns. These are sine wave patterns. Now, this is where knowing your equipment's going to come in handy. If you've got a digital Oscope, then all you have to do is hit your auto button, and it will configure for you, get you in the neighborhood. If you've got a analog scope, then you're going to need to mess with your time delay and your volts per division. And by doing that, as you can see, you'll get a waveform on your screen. Now, as far as your Oscope is concerned, you want to make sure that your coupling is set to AC and not DC, because we are working with AC voltage. Now, once you get all that set up, you should have a pattern on your screen that looks something like that. Now, one thing you want to pay attention to when you're setting up your scope, you want to make sure both channels are at the same settings. So our time is at 0.2 milliseconds, and our volts per division is at 2 millivolts per division. Your may have different settings, different numbers, but you want to make sure that that is correct, both of them at the same. Because when you turn up your volume, you can see, in my case, my wave patterns are not matched. Now, one thing you want to ensure about your amplifier is you want to make sure that your bass and your treble is set to neutral. Now, this amplifier has been sitting in storage for 3 years. I just pulled it out to shoot this video, and of course it's going to be put into line. Well, let's see here, equalizer, there we go. All right, so my bass is set to 0 dB, which is neutral. Make sure any noisemaker stuff is turned off. Any echo chambers, if you've got all that whiz-bangery magic stuff like this thing does. So if you look at my pattern, you can see that we are not equal. And that's what you want. You want to ensure that your two channels are indeed equal. Now, I'm not going to totally worry about this. I'm probably not going to notice much difference, and I'm definitely not going to try to tear this apart and figure it out. So with that said, that's how you look at it on a scope. You want to make sure that everything is lined up properly. If not, then you'll need to make adjustments in your amplifier, whether it's go in and component replacement or whatever. In my case, I'm going to live with it. If you wanted to view this on a AC meter, the scope is really the best way to go because you get a lot of feedback. So here on the meter, you'll get meter movement. So as I turn up the volume, and so what you would need to do if you're going to work with this kind of meter, if you only have one input like this meter does, then you'll have to plug both channels in, set this to a point on the meter that you could remember. Usually you want to work with, you know, centers high enough. Like we'll try to go with 2. That's close enough. So then you'd pull out the other channel. Let's do that. So that was the right channel. This is the left channel. And we could see how much more of a gain the 2 channel has, or this channel has over the other one. Now, if you wanted to read this on a frequency counter, then you just simply plug it into your frequency counter, and there you go. Of course, the frequency counter will not tell you how much gain is on the wire. It's just going to tell you if it's passing the proper frequency. So that was one channel, and this is the other channel. I got my channels mixed up, I think. Okay, so we got 1,000 there. And if you wanted to, and if you had the option, the ability to plug it into a audio spectrum analyzer, whether it's a real device like this or a software device, you just plug it in. It's challenging with one hand, and there you go. I apologize for the wiggly camera. Okay, so that's how you do all that. It's really not too terribly hard, not too terribly difficult. Now the rest of it is purely up to you of what you want to try to achieve and achieve it. But that gives you a good starting point of where to go and how to hook all this up to your test gear. Your manual will also tell you at what frequency. It should tell you at what frequency. If not, then just pick 1,000 hertz. 1,000 hertz is a good number. Another number to select. Wow. Another good number to select would be 400. So what did I do that just messed that all up? Wow. To play with the modes on your your thing here. So if I do 2 channels, you could see what difference that makes. Now if you see a pattern like that, that means you're out of phase. Each channel is out of phase. See how we got a up here and a down here? Out of phase. And so if you don't have anything that whiz-bangery like this, just a standard stock amplifier, and you see that, then you're going to have to try to fix your phasing issue in your amplifier. Now if your audio generator, function generator, has the capabilities of doing sweep, this is something cool, because then you could test your amplifier and see what, if it does exactly what manufacturer claims, or you could test the filtering in it. If you think there's a problem with the highs, lows, medium, you'll be able to sweep it and find out. So we set the low to 20 Hertz. And then we set the high to 20,000 Hertz. And then I'll come over and I'm going to set the RF, or the audio output power, the gain. I'm going to adjust that down to 1 volt peak to peak. And then I'm going to come back over here and change the sweep time from that down to, say, 5 seconds. So for 5 seconds it's 5,000 milliseconds. Oops, apologize for the shoddy camera work. I was looking, using my eyeballs at the in real life and not at the camera. So with that, now we come down and we could look at it. And we could see that it is hitting all the numbers. Now let me turn on my alright, so what you see in there at the bottom, that's the spectrum analyzer. Readjust this a little bit. So now we could see the spectrum analyzer. And so if you have a spectrum analyzer, whether it's computer based or real hardware based, then you'll be able to sweep and see exactly what your amplifier can do. And of course, since you do have, if you have a function generator, moreover a audio function generator, audio frequency generator generally covers that spectrum, 20 to 20,000. But if you had a function generator, it'll more likely go over that, say to 1 meg at least. And by doing that, you can then see what the extreme high and the extreme low of your amplifier is, because the numbers you see in the paperwork, that's what the manufacturer is guaranteeing the amplifier to do. You can really see what it's is capable of doing. And for that, we just go back into sine wave, and we got the 1000 there. And let's say we want, let's say 20 hertz. Why not? Oops. Let's always do that. 20 hertz. And we're going to leave it at 1 volt peak to peak. And we come down and we readjust our scope. And there it is. Let me turn down the power gain. Wrong one. And this is why it's great for you to know how to use your scope. Alright, so now we can see what our pattern looks like at 20 hertz. And then for our frequency on this device, we could take our marker Okay, so our marker is marked. You can see that because the little 3 dots. And then when we look down here, 20 hertz. Now, already playing with this amplifier, I know that it goes to about 25,000 hertz, and then it starts to peter off from there. So it's some cheesy tests that you could even do on your own. Well, that will conclude it for this video. Let me, before we bug out, let me make one recommendation to you for another YouTuber. He's more into audio gear than I am. I'm just kind of like a general purpose kind of technician, where he kind of specializes in stereos, amplifiers, as such. There will be a link below to his channel. His channel name is Old School, and his videos are very easy. He don't get into heavy-duty technical mumbo-jumbo. Very rarely does he do math, but when he does do the math, it's very easy, and it's just an awesome channel to follow. Do yourself a favor, subscribe to his channel, and let him know that Vintage Electronics Geek is the one that sent you that way. Both he and I would appreciate that. And then you too will also have another fantastic resource to put in your toolbox. With that said, we will catch you in the next video, which will be how to hook up a tape deck and do all of this as well. Catch you in that video. Bye for now, and thanks for watching.